follow-up is helping to
You're late.
the
Now you get the Saturn 5.
hackathon. You know,
There's like 3 people in the room that know what that joke is. It's not good. It does have something to do with that.
I was told about that. I remember it now.
I don't know the joke, but I know what the object is.
Yeah. Yeah, you do. Oh man, we're terrible Christians.
No,
Well,
yeah, Christians. Well, remember, we are dedicated to helping students develop in mind as body.
yes, we are. Oh, man, prepare for takeoff. All right. So, oh, by the way, did you guys see that skeleton I printed yesterday? It was a fully articulated skeleton. It was about this tall. We printed out in the printers. Well, I showed that to Mr. Gonzalez, and he wasn't happy. He said it's not big enough. So since we have an array of 12 printers, I printed that skeleton at a significantly larger scale. And it's done now. So it's about that tall. And it pops together. So but we have so many printers. I printed the skull. I printed, then there was these print jobs on the printers. Gonzalez's torso, Gonzalez's hips, Gonzalez's thighs, feet, hands, all this stuff is in. I actually had to use the heat gun a little bit to pop it all together because the plastic's so thick that, but it's all together now and it's fully articulated. I had to reprint his head. I dropped it and shattered the jawbone, but I'll use that head for something else, but yeah. It's fine.
I was going to make a joke, but it was appropriate, so I'll refrain.
That's a post-class, post-recording joke.
Oh, we're recording now. Yeah.
Yeah, we've been online for a couple minutes. All right, so let's hit this. Okay, so we added the ability to store Lambda expressions to our environment last time, right? And kind of the premise behind that was, we don't want to apply that expression yet. It's kind of for later use. So we had to flag it and say, oh, I'm dealing with the Lambda, so I'm not going to do anything with it. I'm just going to kind of store it in place so later on I can do something with it. So what we needed to do here is we needed to go into our apply expression, or an app expression rather, sorry. So where's my app expression? Here's my else. All right. So I have my else. We're going to grab our operator. Now, this operator, up to this point, we're assuming it is a lambda. We can still assume it ultimately is a lambda, right? But right now it's in one of 2 forms. It's either a lambda or it's a var expression. Does that make sense? And if it's a var expression, we need to turn it into the lambda version of itself. All right. So for app expression get operator, I think this guy will just give us that first piece, right? Let's check that. Cadder. Oh, the car of the app. Yeah. But I want to use my helper function. I just want to make sure I'm not doing anything fancy with it, converting it to something or calling apply expression, and I shouldn't be. Blah, 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 get operator. Yeah, just returns a car. Okay, so I can still use this guy. All right, so this guy right here, he will boil down to, I don't need to change that line. Operator will be either a var expression or a lambda expression now, right? So when I call apply expression, when I'm in the body here, I really need to ask a question. I needed to say, if, what is it, lambda exp like that? Okay, if operator is a lambda blah blah expression, if it's one of those guys, then I'll go ahead and call apply expression on the,
Speaking from experience, this will break.
okay.
Because lambda get params won't work on var expression.
Yeah, I got it. Okay, so well, let's just play with our logic here for a second. All right, so assuming this operator is, so what you had to do is you had to move some of these things down into a second let.
Yeah.
Yeah, it's fine. So assuming our operator is a lambda, which in that case, things would not have broken yet. We would have made a good guess ahead of time. If it is a lambda, we're going to do exactly what we did before. Else, if it's not a lambda, then I need to go ahead and do some other things, right? I need to get the value of this guy. I need to resolve that value. So what he was saying is I can't necessarily get my looperands, my low resolved operands, or my low param names. I can't get those things yet, correct? I can only get my operator at that level. All right, and then I'm going to ask a question about my operator. Now, once I know what my operator is, then I can go and get some other things. So I can say, really what I want to do here is I want to ask a question if this guy is a var expression. Let me go that route. I really don't want to have two lets.
Could you have an if inside of your let star?
You can...
You can have a result of being either the var version.
Yeah,
or the lambda.
yeah. Well, you'd have to do a let rec.
Don't we only need let recs if we're...
Yeah, if you're calling it recursively, yeah. So let star, you want to create a function in there?
No. I just want to have a if statement for the definition of operator. And it'll either do the stuff for if it's a var expression or if it's a regular lambda.
Okay. Let me write this out long way and then let's move pieces around.
Okay.
Let's do that. Let's do it the correct way first and then see where we can kind of clean it up because I think this will read better. All right, so if I'm looking at, we'll stick with lambda expression here initially since I already have my let for that. Okay, so if I'm looking at a lambda expression, okay, then what I want to do is I want to create I don't remember if I'm going to need a let or a let star, so I'm just going to go ahead and do that. Is this guy based on things above? Yeah, he's based on looperands, so we do need a let star. All right, so I'm going to go ahead and create a let star, grabbing my looperands, lower, blah, blah, all that stuff. And then the body of that guy will be my apply expression. That's what I'm going to do if I'm looking at a lambda. All right. If I'm not looking at a lambda, then what I need to do is I need to replace operator. If I want all the other stuff to stay the same, I need to get an updated operator. And I'm only using operator in my apply expression, right? So then what I'll do is I'll create a let star. And inside here, we're going to go ahead. So my else to this if means that I must be looking at a var expression, right? So I'm going to call this guy resolved operator. We actually could call it operator. He would be the more local version of the operator, but let's just name it. Kind of, this is our resolved variable. So our resolved operator would be, what is it called? Apply environment? Where's my, actually I'd call apply expression on the var expression, right? So I'll go ahead and call apply Is it spelled out? Apply expression like that. Yep. And I'll pass it my operator along with my current environment. And that should give me now a lambda inside of my resolved operator. Then I'll go ahead and put my other things in there. Except these other things are this last one is the problem, right? So these guys up here oh, these wouldn't work either unless it was a lambda. But I have my resolved operator there. And I can't use my expression there. I need to use resolved operator there as well. That's my actual expression. So when I come into this let, my resolved operator is what I get when I look up my var expression and let it resolve to its variable, right? Or let it resolve to the lambda. So resolved operator will be my lambda. Then the operands associated with this guy is going to be the operators of that resolved operator, the operands of the resolved operator. My resolved operands, to get a list of those guys, I'm going to map this function across my looperands. That's why I have a let star here. And then my param names is going to be get params from my resolved operator here, which now is definitely a lambda. Well, we're not enforcing it to be a lambda, but we've now expanded our definition of an app expression to have the first thing either be a lambda expression or a var expression that boils down to a lambda expression. All right, so that'll be the end of my let star for that one, and then I can come in here and call apply expression, but I'm not doing it on operator anymore. I'm doing it on resolved operator, like that, in an extended environment with all those other things. It's the end of the road, right? Oop. I'm lost. There we go. All right, so this should now allow me to have a remember expression being a lambda. So this guy should take in, have a variable a equal to a lambda that takes in a single parameter and boils down to a var expression of whatever that guy is. Then I'm remembering b to be a lit, and then I'm calling app expression, passing it the first element as a var expression, and we'll also want to test this on an old school lambda expression, but passing the first element of a var expression, and then the parameter we're passing it as another var expression. So b is a 5, we're passing a 5 in for the a, which comes in as c, which boils down to the value of c, which should be a 5. So this guy should boil down to a 5. What broke? Last argument must be a list, but received a B. Oh, is my syntax for app expression wrong? So this is a bad test case. This has to be a list of those guys. And app expression get operands.
There's a big error along the line because I was trying to fix so many things, and you're telling me that that's wrong.
Let's see. What's my cooter expects a pair given false? So when I say get operands, which line is that coming from? It's coming from right here. Get params from resolved operator. My resolved operator should be my lambda. Is my lambda a correct format? So this is a lambda, or lambda takes in, it's a lambda expression, it takes in a list of params.
Yeah. Yeah, that's fine.
That's the, where's my builder? Where's my constructor? Here. So list of symbols and a lambda calculus expression. Seems like we're fine there. So my remember expression, I'm remembering A is equal to that. Then I'm remembering B is equal to that. That looks fine. Then my app expression takes in a lambda calculus expression and then a list of params, right? List of var expression. So a list containing a single var expression. Yeah, that looks right to me. He's yelling about the cooler expecting a pair, but it got a false.
136.
So that's get operands. So it got a false from that. So I must not be looking up my lambda correctly, because a false comes from our environment, right? So our environment gives us either the value of a variable. So in this case, we are presumably looking up A and getting a false for it instead of this guy. So when I say remember A is this lambda, let's go look at a remember expression. So here's the symbol. It's the counter. Here's my value. If the value is a lambda expression, then I'm going to extend the environment with that symbol and my value unchanged, right? So that should give me an accurate expression, let's say. So what I'm going to do here, I want to see what my environment looks like. So I'm going to remove my app expression here. So we're going to debug our code.
Oh, because of the app exp is like taking a list and not a variable.
No, it's
So
just-
like,
I have a list here.
list.
All right, so now I want to print out my environment. So I'm actually going to do, the last thing is a remember, so let's just do that. So what I'm going to do is inside of my remember expressions, right now I boil down to my extend. Oh, actually, do my remember show my output?
That should be fine.
Okay, so I'll actually see it.
True.
Oh, but I want to see what the environment looks like. So I have two remember expressions. So let me just go into a remember expression. And actually what I can do is I can do it at the end of my block expression, just for the sake of testing. So at the end of my block expression, here's my lambda. If it's null, I'm going to boil down to a, this is going to be kind of
The ENV.
funky. ENV will be a list, right?
Yeah.
Yeah.
Just spit it out for us.
All right, so we have B is 5, and we have A is a lambda with a C with a C. Okay, so that looks correct to me. Okay, so now what I'm going to do is I'm lost. Where's my block? Oh, here, right here. So I'm going to call apply env. Is that what it's called? Apply env like that?
What are you trying to do?
I want to look up A in my environment.
Oh, okay.
A and the env. And I'll make that into a list because that's what this guy's expecting to return because I'm consing onto this. So I'm hoping to get the value of A at the very end of my block expression here. And I should have a false in there at some point. Okay, so it looked up the A, true. It looked up the A, and then here is the value of A. So that looks correct to me. Just to make sure, let's look up the value of B. We should get a false the first time through because we don't have that yet. Is that true? We don't have that yet?
No, I think
Well,
You have a B as a 5.
that's interesting.
yeah, but it shouldn't be the very first time through. Very first time through of my remember. So I'm going to, my block expression will come in here and it will say, so here's all my expressions. So everything but the word block is what this guy is. And I'm going to go through these guys. I'm going to say if it's empty, if I'm out of stuff to do, then it's what we're going to print out here. Oh, by the time we get to empty, B has been defined. So we're fine. That's why it's true. And B is equal to 5. So my environment contains all the stuff it's supposed to contain. So I'm comfortable with my environment at that point. Okay. So now we still have broken code here. So when I call app expression, I'm telling it to look up my var expression A. It should get a value here. And, well, actually, no. My app expression, var expression A, we saw was,
Never look up, no.
that's in a var expression. That's here.
No, can you scroll into code? I cannot.
Hold on. So this is var expression. This is an A. I'm calling apply env on that expression in my environment. We just did that inside the block. We saw it worked. Okay, so this guy should give me, should add into my environment a variable called A with the lambda associated with it. This should give me a variable called B with the 5 associated with it. So now for my app expression, I asked the question about the first guy. So let's go to app expression. It's in my else, right? So here's my else. So I'm going to grab the operator here. And my operator is going to be the get operator from the expression, which is going to be the car, which should be that guy. Actually, hold on.
I think var expression. Does it just spit out as A?
1 second. The car of, so app expression get operator, we saw that returns the car of my expression.
Yeah.
But doesn't my expression look like this?
I think it's EXPR, not the result one. I don't know why you put that there.
Hold on, let's look at what app.
Cause like,
I don't
I've
think
got
app
like,
expression has the app exp at the front of it. So it would just be the list containing A and B.
Yeah.
Or in this case, the list containing just A. Oh, so that's not correct syntax for app expression?
No, it is.
Well, I'm saying, I think when app expression.
Oh, when I call my constructor here, it just gives me a list containing those things.
Yeah.
So the car of the list will be this guy.
Yeah.
Okay, good. So we have it written right. All right, so right here, where's it at? Operator, this guy will be equal to the car of EXPR, which should be
okay.
this
but
guy right here. Go ahead.
Just go up. Okay, so resolve operator, you have apply on to the operators of that, and then the next line app expression get operands. Why would you pass in the resolve operator though?
Oh, that might be it. For loop
Like, can you pass an EXPR though? Because it's like A and B, so now you have A out,
Yeah.
now you got the rest is the B. So
Yeah.
why would it be the resolve operators?
Line 245, right below it.
Yeah. So let me look at this line. So resolved operator is going to be apply expression on that operator that should get me out my lambda.
Yeah.
Looperands, this should give me the
Rest of the stuff.
get operands from.
Your app expression.
App expression, so it's not the operator though, like because you
Oh,
pass
it's from expression, EXPR,
Mhm.
why is it there?
like that.
Yeah.
Yeah.
Yeah, because I'm trying to get the parameters passing into it for this guy. Yeah. And I changed that purposely. So I was like, oh, why is this expression? Because it is expression above. All right, and there's our 5. So now I got us the right answer. And then we should test this also then on a app exp var expression. We can even use, well, we'll use something completely different. We'll say F. Well, actually, no, hold on. This is not a var expression. This is going to be a lambda expression because I want to use my other form, right? Lambda expression, passing it an F. And then we're going to just say var exp F. And I'll go ahead and pass in B as my parameter. So this should also give me a 5. So I should get a second 5 out of this. So this version here had me resolve A to a lambda, where this version here actually has me taking in a lambda, boiling down to, it should be a 5 again, but proving that we can handle both forms now. An unresolved lambda, which is in a variable, or a direct lambda.
It needs to be a list though.
Which part needs to be a list?
The B thing, right? Yes, no. Because the first one you
Oh,
said-
list of parameters. This is a list of parameters. Thank you. So I can, well, I'll just put list around it. That allows us to support multiple parameters being sent into our app expressions. This should give us 2 5s. There's our 2 5s. So we support lambda as well as var expressions. Okay, so now we have the ability to store lambdas inside of our environment. Now, what would be next? I have functions. My app expressions now are a little bit more powerful, right? Because now I can define functions, use them later. What's really a thing we're missing? What's limiting? What can we do in our lambda expressions right now?
Output whatever we put in,
Yeah, that's basically it, right?
or output it numerous times.
Yeah. I can do block expressions where we do a whole bunch of stuff in there or something like that. But, you know, when we think about programming and we think about logic, what's the first thing that comes to mind with logic?
Conditionals.
Okay. Do we have conditionals already?
Yeah.
We have conditionals, but we
Yeah,
we kind of have ghetto conditionals, right?
Yeah.
All right. You know, but I think our conditionals are acceptable enough. We operate off of the C base for our conditionals, 0 or not 0, right? Okay, so but when we think about logic, what are we usually doing?
Me.
Math. We don't have math.
Yeah.
Yeah.
Hold on, I know a guy that could
Yeah,
go
we-
for us.
Yeah. All right, so we'd like to have some math into our code. So if we go to our you guys might find this interesting. So this is a data science class I'm teaching, and so if you're a college football fan, this is a data plot of head coach salaries compared to their team's rankings. So you see the number 1 ranked team, the coach makes, looks like around 7 million. So, well, they're number 1 ranked. He's worth every penny, right? Presumably, it probably brings a lot of revenue to the school, whatever. But where they're really getting screwed over is, so like this guy, he's making 7 million and he's not even top 10. where are we at here? So this guy here's making 4 million and he's barely top 70. That's not worth it, is it?
It's a pretty good gig for him.
He's 121st. I think pretty much.
Now they're getting a great deal on this dude. This dude's making like, you know, 1.25 million.
He's number 10.
And he's either 10 or he looks like he's exactly 10.
Yeah.
That's if you think about, you know, cost per rank,
He's getting ripped off.
well, yeah, or the school's getting a great deal. Any way you cut it.
Guy at like 120 something, 121st. He's making like $2 million.
Yeah,
That's
he shouldn't even be employed.
I can do that.
Yeah. Like, did you know there's only 117 teams that compete?
I mean, literally, to do that, you just get a bunch of players together. And
You just need people on the field. You just need people on the field. You probably don't have to win.
Yeah, but you're coach, so you have to
Yeah.
tell them.
How many losses? I mean, how many wins must you get to be 120th ranked?
The coach just says, listen to the quarterback.
Listen to the quarterback. Yeah.
Don't play
They get one win, like maybe every 10 games or something like that. Like, you're rank $120, you're fine. Yeah, but I thought that was kind of an interesting thing. Okay, so 470. All right, so we go back to our, somewhere in there I have my grammar, right? So here's my grammar. Now, we might have something called a math expression. In fact, what I'm going to do here is I'm going to recreate my grammar farther down here. And why don't we just say continued. That way we have a fresh thing and the font doesn't get too small. And then we can even put the original one right above it. That way it's on two separate screens. Okay. So we want to have something maybe called a math expression. Now, when you think about math, what are the things that we should be able to do at the bare minimum? Well,
Plus and minus.
addition, subtraction, division, multiplication, mod. So maybe think about those guys as our,
Exponents.
well, possibly. But is that a good enough starting point?
Oh, yeah.
Good enough starting point, because with loops we can handle exponents, right? We can implement our own calculate exponent lambda.
Loop, we can handle multiplication. Really, all we need is addition. Maybe division.
Yeah, but how are we going to get doing things negative? Yeah, negative values will be rough. Right now we can store negative values, so addition probably would work. We could hack it out. You're right. But let's give ourselves a reasonable calculator. All right, so we want to be able to do these things. Now, what would you call these? Okay, so this is actually a different grammar, correct? We have a language of operators here, don't we? So if I kind of, so if we have a,
There's another day we can use, because we already use operators in our code. So if we read it operators, it's going to get confusing real quick.
we'll call it a math op. So language of math op. So math op language. Okay. So a math op language is, now this is what is, just like we have the language of numbers, right? A math op language is a language that contains, it's a plus or minus or times or divide or modulus. Okay, if we want modulus to be represented differently, we can do that, but this is Java enough for us, so let's just stick with this. All right, so that's what a math op language is. It's what operators are. All right, so we go back to our math expression. So our math expression is going to look like what? It's going to be, maybe we have math expression at the beginning of it. something like that, followed by a single math op, followed by a LC expression, followed by another LC expression, something like that. All right, so we're going to need to now kind of create almost a second interpreter, and we probably could say we don't need to, but if we kind of think about maybe the history of computer science, in the early days of CPU design, we had something called a math coprocessor. So you had the normal processor, and then you had this like secondary dude that did the math stuff for you. Go ahead.
Are those just generic Lambda expressions, or are we assuming that those will be lit expressions?
We're going to have to, well, or var expressions.
Or var expressions.
Yeah. Something that boils down to a number, but we'll still call them lambda calculus expressions now, and they'll just make our assumptions, but you're right. So for those of you who've done anything with processor stuff, we used to have something called a math coprocessor. What's that called now?
GPU.
Well, technically the GPU does do a lot of math, but that we don't use the GPU for just doing addition for normal math stuff in our.
Aren't they all just built into the CPU?
Yeah, right. What's it called in the CPU? That's the trivia question. ALU. Yeah. So arithmetic logic unit. So we have this thing called the ALU, and that does our math, and now it's part of your processor, where before it was the secondary thing because we only fit so much crap into our processor. Okay, so but we're going to kind of model that with our language because as was pointed out, our interpreter is getting a little beefy, right? So maybe we want to start kind of compartmentalizing a couple things. Would it make sense? Don't just have things in separate functions just to have things in separate functions, but maybe we're going to have something that performs or maybe applies math. Okay, so because right now we have something called apply expression. So maybe we have something called apply math expression specifically. So apply expression we can add math expression to it and do all sorts of stuff. But we're going to go ahead and piecemeal this out a little bit for kind of reasons where we're going with types and things like that. So this is not a necessity. We could certainly put math expressions inside of apply expression and have it work just fine. But let's go ahead and effectively create a helper function. Okay. So what this guy's going to do is we're going to have a math expression. Oh, by the way, you should never take a heat gun to super glue. The fumes it gives off are
Did you burn your finger?
probably.
Was it a bad whistle, insert whistle here, or a whoopee?
Well, it was just more bad. Yeah, like hurts. Like, yeah, but then and also don't hold small plastic parts while aiming a heat gun right at your hand.
That's real smart.
Because you have nerve endings in your hand.
Not anymore.
Just use paint thinner, super glue. It breaks it down real easy.
Well, no, I wasn't trying to melt the super glue. I was trying to melt the plastic I'd already put super glue on.
Oh.
Yeah, I just didn't care about the super glue. Super glue was just in the way. It was just a innocent bystander of the melting process. We had to open the garage down there. Okay, so we have this math expression. A math expression is going to be a math exp. We're going to take in a math op, so something that follows the language of math ops. Make sense? Okay, so we're going to have a secondary thing for asking is something a math op, for identifying that. All right, and this guy gets applied to two lambda calculus expressions. Now, I'll actually let you choose. If you want to embed math expression inside of your apply expression, you can. In fact, if we're talking about correctness, because a math expression is still an expression, it does belong inside of apply expression. So we would have to come up with a reality of why math might not be an expression. Go ahead.
Well, could we potentially have a math operator or apply math operator?
Well, that would be like a helper function that did that, but there's not a reason why we can't have that inside of our apply expression. You could have a helper function for saying apply math, and that kind of becomes like our ALU thing in case we want to add things to the language of math operators. You know, so we could do that. If you looked ahead in the book a little bit, the book starts talking about the difference between like expressions and statements. And so right now we have a function called apply expression, and apply expression is, it handles anything that is a expression, right? So if we're calling it a math exp, we're kind of saying this guy is likely an expression, right? That's kind of a thing. All right, so realistically, we probably then should add this to apply expression, and then we'll just use our next example, next class, for kind of having a separate thing as we add a new kind of thing with types and statements and things like that. So what we want to do for our homework, so we're going to have math expression, math op, LC expression. So for our homework, we're going to implement math exp. In terms of its constructors, the language of math ops with an appropriate predicate, and well, yeah, I think that's actually probably enough. Implement math expressions in terms of its constructors, the language of math ops with an appropriate predicate. All right, so the idea would be we should, at the end of this, we should be able to expand our lambdas to take in like a lambda AB and then do like a plus AB, math expression plus AB. Make sense? Huh? No, I'm not giving you a test case this time. You should be able to make your own test cases. Go ahead.
So is math op something that we have to like add into the environment, or is that just
Math op's a different language. You don't actually have to probably add it. I would add it because part of the reason why, like Blaine suggested, maybe we have an apply math function, like a helper function, where if we want to kind of add new math, so for instance, Pell suggested maybe we have exponents, right? So for this assignment, we're not adding exponents, but if at a later point in time we want to say, oh, let's add exponents, all we'd have to do is expand what a math op is to include an exponent, and then add to apply math the logic for exponents, and we don't have to touch apply expression, because apply expression calls apply math.
That makes sense.
Does that make sense? So we're just kind of compartmentalizing. So I guess that kind of accomplishes, so thanks for that, Blaine. That does kind of accomplish what I want us to do, start separating out a little bit. So we'll still keep math expressions inside of apply expression, but we're going to handle the ALU type of thing by having an apply math function. So I'll just put a little note here. Write apply math as a separate function so that we can easily expand the math we know how to do in the future. Question over there?
Well, I was just thinking, but I answered my own question, so never mind.
Oh, you raise your hand when you think?
Well, no, I had a question and then I answered my own question.
Oh, okay, I got you. Was it a good question?
No.
Oh, good. All right, so does this make sense? So right now we're let's say we're going to purposely limit our math op language to not include exponents. You know, even though Appel wanted to do it, and I fully expect he's probably going to add it. What's going to actually happen is he's going to add it and turn the homework in 4 hours late. It's a trade-off. It's a thing. Actually, no, he probably won't turn it in 4 hours late. He'll either turn it in a day early or 4 days late. One of those two. It's a thing. It's a personality quirk. I love it. It's fine. It's just part of the package. You get it, right? All right. So the idea here is that we're going to purposely constrain ourselves to non-exponents, And then if we wanted to add exponents, we'll just do it in class real quick next time and see that we just add that to apply math and all of a sudden it magically works.
Okay.
Cool? Got it? Questions, comments, concerns, bribes? All right, I'll see everybody on Monday.